Okay, so this video lesson is it's in addition to the video lesson from before, where we're looking at concentrations of solutions. So it's just a special case of concentration. Again, concentration, we're looking at a quantitative way of describing the amount of solute that's present in the solution. It's similar to solubility in that it's a ratio of the amount of the solute to the amount of solution, so the quantities of those, and as a ratio. And we looked at several different ways of expressing it there yesterday, where we might have the mass to the volume to volume, or the mass to mass. And generally the mass to volume is one that we have with aqueous solutions. Well, most of our solutions that we're looking at are aqueous, so it does make sense to have a combination of the amount of solute to the volume of the solution, and it just makes things a lot easier to calculate as well if we have volume rather than having to weigh out the mass of the solution, take into account how much of the solute that's present in there. Volume is just relatively simple to measure. So what we're going to look at is a very special concentration known as molar concentration. Okay, it's the concentration when we use the moles of the solute rather than the mass. Okay, a little bit extra calculations if we have mass to start with, but in the end, what we get is an actual amount of the solute that we can compare number for number rather than mass per mass. Okay, like we've been looking at with moles all along. So this is the sheet we're looking at, this blank one, and there's not really much of a note. I just put a couple little notes at the very top. Okay, so at the very top we're going to use this formula. Okay, and we'll use those symbols. Okay, so concentration, it's going to be C, okay, is equal to the number of moles divided by the volume in liters of the solution. Okay, and we can use this little formula here, C with this triangle as well, C, N, and V. Okay. One other little thing, so it's going to be moles per liter. One other little thing too is that sometimes we use a little short form for these symbols, and I'll show that to you in the lesson. Okay. So let's take a look at the first one. Very simple. Okay. Sodium hydroxide solution contains 0.186 moles of sodium hydroxide in a 0.250 liter solution. Calculate the molar concentration of the sodium hydroxide solution. Well, I've highlighted already the given information, and I know it says calculate, so that's my question. I'm going to find out the concentration. Okay, so I've got the moles, and I use the units to actually help me out, and the volume in liters. Okay, so those are my two bits of given information. I've written down the formula I'm going to use. Okay, I'm looking for the concentration, so I just divide those two values, and I get my value. As you can see, there's 3 significant digits in both cases, so I retain 3 in the final answer if we're looking at that. Okay, so the final concentration is 0.744 moles per liter. Just one other way that we can show concentration, and it shows it a little bit clearer, is to use square brackets. So it's the same as the concentration, but these square brackets tell us that it's the concentration of the sodium hydroxide. It's really clear that way. Okay, so you might see square brackets. Also, you might see something else here, 0.744 big M, and that's now a unit. It's not a symbol, so unit, and it means moles per liter, or moles per liter, or you might also see it as moles liters to the -1. Okay, so different ways that you might see these units. All right, so let's try the next one. I'm going to get you to do this one. Okay, so just start it. So the concentration of sodium chloride in typical blood serum is approximately 0.140 moles per liter. What amount of sodium chloride is in 0.120 milliliters of blood serum? So this one's a little bit harder. I'll just start it. You're going to have to use a different version of the formula, same formula, but rearranged. We're looking for amount. Remember, amount means moles. Okay, And also, we've got a volume in milliliters, so we're going to need to change that. So there's quite a few things to do. So go ahead and try that. I'd pause here. Okay, now you can check. Now you can take a look at the answer. Okay, I'll just briefly go through it. So we've got the concentration, that's moles per liter, okay, or molar concentration. We have the volume. We need to change it into liters. Okay, so we divide by 1,000 to get liters, and then the formula is N equals C times V. We look at it. If we want to know what N is, we'll cover up the N, and we see that we have to multiply those two symbols there, those two quantities. Okay, so we're multiplying the two of them, and we get quite a small number. There's still 3 significant digits in both, so we'll retain 3 significant digits. And I haven't done that here, but you can see that it should actually be 3 significant digits in the answer. Okay. Last one. What volume? Here we're asking another question. What volume of 5 moles per liter glucose solution contains 2.5 moles of glucose? Okay. So go ahead and try that. Again, a different version of the formula is needed. So pause, try the question. Okay, now we're back, and we'll go through the solution. So we know what the concentration is. It's 5 moles per liter. We know that we want 2.5 moles. You have to use a different version. Basically, if we want the volume, let's go back to here. If we want the volume, cover up the volume, it's going to be moles divided by concentration. So here's our formula. We're going to divide the two values. We end up getting liters in the end, so half a liter is the final answer. Okay, and a therefore statement would be good. Okay, that's the video lesson. What you'll do is there's some more practice on the worksheets to do, and then also we will be doing this activity where we calculate the concentrations of a copper sulfate solution, molar and percent, and then we're going to go an extra step and try to apply it and see if we can figure out what happens if we dilute it. So we add some more water to the solution, see if it actually gives us, if we can kind of figure this formula out without having the formula, and then use that formula as an application of molar concentration. Okay, thank you very much.